Hello everyone, welcome to our class. My name is Kuo Chen Lee. In today's sections, we will continue to talk about hardware detection, error detections, and recovery. And this is today's outline. And we will mainly discuss the device drivers and how to manage it. Then we will talk about how to manage hardware. Same as the previous sections, we will use Windows Server 2008 as an example to show you how to manage hardware. And each hardware component installed on a computer has an associated device driver. The job of the device driver is to describe how the operating system uses the hardware abstraction layer, HAL, to work with the hardware components. The HAL handles the lower-level communication tasks between the operating system and the hardware components. By installing the hardware component through the operating system, you are telling the operating system about the device driver it uses. From then on, the device driver loads automatically and runs as part of the operating system. Windows Server 2008 includes an extensive library of device drivers. In the base installations of operating systems, these drivers are maintained in the file repositories of the driver store. And some service packs you install will also include updates to the driver store. The driver store folders also contains subfolders for localized driver information. And you will find subfolders for each language component configured on the systems. For example, for localized US English drivers information, you will find a subfolder called ENUS. And every device driver in the driver stores is certified to be fully compatible with Windows Server 2008. And is also digitally signed by Microsoft to assure the operating system of each authenticity. When you install a new plug-and-play compatible device, Windows Server 2008 checks the driver stores for compatible device drivers. If one is found, the operating system automatically installs the device. Every device driver has an associated setup information file. And this file, which ends with the .inf extensions, is a text file containing detailed configuration information about the device being installed. And the information files identifies any source files used by drivers as well. And source files has the .sys extensions. And drivers are also associated with a component manifest, component.man file. The manifest file is written in extensible markup language, XML. It includes details on the driver's digital signature. It might also include plug-and-play information used by the device to configure itself automatically. And speaking of new device drivers, Microsoft recommends that you use the signed device drivers whenever possible. Every device driver in the driver cache is the digitally signed which certifies the drivers as having passed the extensive testing by the Windows Hardware Quality Lab, WHQL. If a device driver doesn't have a digital signature signed by Microsoft, it hasn't been approved for use through testing, or its file might have been modified from the original installation by another program. This means that unsigned drivers are much more likely than any other programs you have installed to cause the operating system to freeze or the computer to crash. In some situations, you might find a particular device doesn't have a signed device driver. Here you should check the manufacturer's website to see whether a signed driver is available, because sometimes there is a signed driver, but it's just not distributed with the device or on the Windows Server 2008 distribution disks. And if a signed driver isn't available, you might find that you have to use an unsigned driver. And if you have to install an unsigned driver, proceed cautiously and remember to monitor the system closely. If you find that the system is imperceptibly freezing or crashing, the unsigned driver is probably to blame and should be rolled back or uninstalled. And remember, any type of faulty driver can cause the system to fail. Even a driver for display adapter, a network adapter, or a sound card. To prevent problems with unsigned drivers, Windows Server 2008 warns you by default when you try to install an unsigned device driver. And you can also configure Windows to eliminate these warnings or to prevent unsigned drivers from being installed altogether. To manage device driver settings for computers throughout the organizations, and you can use a group policy. And when you do this, group policy specifies the least secure settings using one of three configuration settings ignored. Use this setting to allow users to install any unsigned driver without having to see and respond to a warning prompt. The second, warn. Use this setting to prompt users each time, either to continue with the installation of an unsigned drivers or to stop the installations. And block. Use this setting to prevent users from installing unsigned driver software. When group policy is set to ignore or warn, and you can install unsigned drivers when group policy is set to block. Unsigned device drivers can be installed without first overriding group policy. Then you can configure device driver sign-in settings on a pre-user basis using the code sign-ins for device drivers policy. And this policy is located in users, configurations, administrative templates, system, drivers, installations. When you enable these policies, you can specify the actions to tag as ignore, warn, or block And after you enable it, the system doesn't implement any settings less secure than the established settings. And to view the detailed information about a device, open a device property dialog box, as shown in figures. And most devices have at least two tabs, either general or properties, and general property or generals and drivers. The most important information on general tabs is the device status. If the device is disabled, you have an option to enable the device instead, as shown in figures. And you can temporarily disable a device by selecting Disable on the driver tab. If you later want to enable the device, click the Enable Device button on the General tab, and then when the troubleshooting wizard starts. And the driver tabs shown in figure provides basic information about the driver provider, creation date, versions, and digital signatures. And you should be wary of any drivers that list of the providers as unknown, as well as drivers that are listed as non-digitally signed. Drivers signed by Microsoft are listed as being signed by Microsoft Windows or Microsoft Windows hardware compatibilities publishers. If no driver files are required or have been loaded for the device, and you will see a message stating that. Otherwise, you will see the names and the locations of all associated files, including an icon that indicates the sign-in status of each individual file. And devices often have other tabs, such as Advanced, Resources, and Power Management. Most network adapters have an Advanced tab, and these options can control transmission options and the settings that causes the most problems is speed and duplex. Most of the time, you will want this set to auto detect or auto negotiations. And sometimes, however, to correct a specific problem, you must use a preset speed and duplex settings, such as 100 megabit per second half duplex or 1000 megabit per second full duplex. And any device that uses system resources will have a resources tab like the one. And the resources tab options show the device resources that are currently assigned and their settings. And there are 4 types of device resources. The DMA. The DMA channels used by the device. Values are shown as integers, such as 02. And memory range. The range of memory addresses used by the device. Values are shown in hexadecimal format, such as this. And I/O range. The range of the I/O port used by the device. And values are shown in hexadecimal format, such as this. And IRQ line. An IRQ line used by the device, values are shown as integers, such as 10. And devices can use multiple I/O and memory ranges. For example, the video graphic adapter, VGA, adapter on one of our computers and use 3 I/O ranges and 3 memory ranges. Additionally, multiple PCI devices can share the same IRQs when using the advanced configuration and the power interface BIOS. And this because the ACPI BIOS allows IRQ sharing. Device drivers are essential to the proper operations of Windows Server 2008. A faulty device drivers can cause many problems on your systems, and everything from unexpected restarts to applications hands to blue screens. To make it easier to detect and diagnose problems, and you should maintain an inventory of all installed device drivers on systems you manage. And you should then periodically check manufacturers' websites for known problems with released device drivers and for updated drivers. And be sure to check the driver date as well as the driver's versions. And next, check the driver version information for the drivers you downloaded. To do this, extract the downloaded driver files to a folders. In the folder, you should find .dll or .sys files. To continue with the installations of downloaded drivers, check to see whether the driver downloads includes a setup program. If it does, run this program so that the proper files are copied to your system. And by default, these wizards can search for updates device drivers in the following locations: on the local computer, on the hardware installation CDs, on the Windows Update site, or your organization's Windows Update server. In addition to code sign-in and search restrictions, and you can use group policy settings to allow or prevent installations of devices based on the device type. The related policy settings include the following: allow administrators to override device installation registration policies, allow installation of devices using drivers that match these devices' setting classes, and allow installation of devices that match any of these device IDs, or prevent installation of drivers matching these devices' setup classes, or prevent installation of devices that match any of these devices' ID, and prevent installations of removable devices, and prevent installations of devices not described by other policy settings. And occasionally, you will find that an updated drivers doesn't work as expected. It could cause problems such as device failures or system instability. And if you suspect that an updated driver is causing the systems or device problems you are experiencing, and you can attempt to recover the system to the previous installed device drivers. If the driver file hasn't been updated, a backup drive files won't be available. In this case, the rollback drive path will be disabled, and you will not be able to click it. And in this case, you should check the manufacturer's website for available versions of the drivers for the device. And Windows device drivers for plug-and-play devices are loaded and unloaded dynamically. And you can remove the drivers for device only when the device is plugged in. This means the proper ways to remove a device from a system is first to uninstall its related device drivers, and then to remove the device from the system. And one reason for uninstalling a device is to remove a device that you no longer use or need. And at this point, you can shut down the system and remove the related hardware components if you want to. However, you might first want to check to see how the computer operates without the device in case some unforeseen problems or error occurs. So, rather than removing the device, you will want to disable it. Disabling the device prevents Windows from reinstalling the device automatically the next time you restart the system. Sometimes, when you are troubleshooting and trying to get the device to work properly, you might want to uninstall or unplug the device temporarily. Here you can disable the device and then monitor the system to see whether problems previously experienced reoccurred. Or you can reinstall the device to see whether normal operations are restored. Uninstalling and then reinstalling the device forces Windows to go back to the original device and registry setting, which can sometimes recover the device. And after you have uninstalled device drivers, one way to get Windows Server 2008 to reinstall the device is to reboot the computer. And you can also try to rescan for devices using Device Manager by choosing Scans for hardware changes on the Action menu. And either way, the operating system should detect the uninstalled device as new hardware and then automatically reinstall the necessary device drivers. When the device isn't working properly, sometimes you can completely uninstall the device, restart the systems, and then reinstall the device driver to restore normal operations. To prevent the device from being reinstalled automatically, disable the device instead of uninstall it. You disable a device by right-clicking it in Device Managers and then selecting Disable. And Windows plug-and-play technology does a good job of detecting and automatically configuring new hardware. However, if the hardware doesn't support plug-and-play or it isn't automatically detected, you will need to enter information about the new hardware into the Windows Server 2008 system. And you do this by using the Add Hardware wizard to install the hardware device and its related drivers on the system. And you can also use this wizard to troubleshoot problems with existing hardware. Although Windows Server 2008 doesn't detect or set up non-plug-and-play devices automatically, it does maintain a driver cache for these devices. And this driver cache has hundreds of drivers, any one of which you might be able to use. And you might also be able to use an older driver if a Windows Server 2008 device driver isn't available. And in either case, you install the device using the Add Hardware wizard. And when the device isn't working properly, sometimes you will want to uninstall or disable it. Uninstalling the device removes the driver associations for the device so that it temporarily appears that the device has been removed from the systems. So the next time you restart the systems, Windows Server 2008 might try to reinstall the device. And typically, Windows Server 2008 reinstalls plug-and-play devices automatically, but does not automatically reinstall non-plug-and-play devices. And Windows Server 2008's built-in hardware diagnostics can detect many types of problems with hardware devices. If a problem is detected, you might see a problem report and solutions balloons information informing you of a problem. And you can also access the problem reports and solutions consoles in control panel by clicking the System and Maintenance link and then clicking Problem Reports and Solutions. And keep in mind that if the device drivers aren't installed properly, and you won't have a check for solution options, and instead, you will have a reinstall driver button. So whenever a device is installed incorrectly or has another problem, Device Manager displays a warning icon indicating that the device has a problem. If you double-click the device, an error code is displayed on the General tabs of the device's Properties dialog box. As the table shows, this error code can be helpful when trying to solve device problems as well. And most of the correction actions assumes that you have selected the General tab from the Device Properties dialog box. And you can check the error message and take the correction action from the tables. And anyone who remembers IRQ conflicts will be thankful that the current computers support the ACPI BIOS. With the ACPI BIOS, resources are allocated automatically by the operating system at startup. And multiple devices can share the same IRQ settings. However, the ACPI depends on plug and play, and devices that are not fully compatible can sometimes cause problems, particularly legacy ISA devices. If you suspect a device conflict is causing the problems with the current device, check the conflicting device list in the lower portions of the Resource tab. It will either list no conflict or the specific source of a known conflict. In Device Managers, you can quickly check resource allocations by choosing resources by type or resources by connections on the View menu. Note also that several devices have a warning icon with an exclamation point. And this is because the device isn't configured properly, not because there is a conflict. And another way to check for conflict is to use the System Information Utility, msinfo32.exe. And you can try to resolve resource conflicts in several different ways. Some devices use jumpers to manage resource settings. And in this case, the operating system cannot control the resource settings. To make changes, you must shut down the computer, remove the device, change the jumper settings, and then replace the device. In some cases, the jumpers are managed through software rather than the actual jumper switch. Here you would use the device setup or configuration utility to change the resource settings. For PCI devices, you can try swapping the cards between PCI slots. This will help if the IRQ or other resource settings are assigned on a per slot basis. As is the case of some motherboards, you might be able to check the motherboard documentation to see which IRQ interrupts are assigned to which slots. In any case, you will need to experiment to see which card configuration works. For PCI devices, a conflict could also be caused by the device drivers and the way it works with the ACPI BIOS. And you should check to see whether an updated device driver and a BIOS updates are available. And installing one or both should resolve the conflict. And as a last resort, you can change the resource settings manually for some devices in Device Manager. And in figures, both ISA and PCI devices are using IRQ settings. And you will note that each ISA device has a separate IRQ settings, while multiple PCI devices share the same IRQ settings. And this is very typical. Note also that several devices have a warning icon with an exclamation point. This is because the device isn't configured properly, not because there is a conflict. And in this example, there are no conflicts. And as shown in figure, a list of all resources that are in use is displayed. Again, keep in mind that devices can share IRQ settings thanks to ACPI. So what you are looking for are two unrelated devices sharing the same memory addresses or I/O ports, which will cause a conflict. Keep in mind that the related devices can share memories, address, and I/O ports. And in this example, the Intel PCI Express root port share the same I/O port as the standard VGA graphic adapters. And the PCI bus shares the same memory addresses as the motherboard resources.